All right, we're back. We're going to do the OSPF side now. And if you watch part one, you know that we went through 3 different topologies here, and now we're going to convert this middle topology from a static routing to an OSPF topology. So I'm going to go ahead and just sort of sever these connections here. So we'll get rid of maybe this one and this one and this one and this one. And we'll move our router 1 out. We'll put router number 3 in. Move router 2 out. And remove router 4 in. And all that we're going to do is OSPF. So the connections will be the same, right? So notice that I have not changed my VLANs at all. And I want to make sure that I wire this in the right way, because I screwed that up last time. Right? So now, config T. Now I don't want to change anything with the hosts. I don't want to worry about any of the other configurations, so I'm going to use the exact same set of IP addresses. And we'll make sure that we're using the right one. No shut. There we go. And so I'm going to say IP address. Well, I was using 3.62. 3.62, and the key, of course, is the mask. There we go. And now let's go ahead and connect our other interface to the next VLAN up, which was here. And I'm going to say, well, first we'll do a no shut. Oh, I gotta go to the other interface. Jeez, I'm losing it, people. I'm losing it. There we go. Now our IP address for this one will be on the 64 net. So as you can see from our labeling, we want this one to be 125. There we go. And let's connect our other friend here, F0/0. You will go to port 9. A little coffee. And this will be the other side of the 64 net. So this interface will be 126. Whoops, 3.126. 192. And we'll do a no shut. Go. And let's connect our last interface. Remember, this is going to be in the next group of ports, and we will make this interface 3.190. All right. So maybe what we'll remember here is that we've got VLAN 100 is for 192.168.3.0/26. And VLAN 164 is for 192.168.3.64/26. VLAN 1128 is for 192.168.3.128/26. So that's my mapping of VLANs to subnetworks. Now in the real world, what you would also have to do is figure out what you're going to do with the 3.192 network, because it doesn't exist. So a very common approach is to black hole route that, or to say I'm going to send those addresses to dev null, and or to a null route. And in that way, nobody thinks that the network is alive. The routers don't try to forward it there, and the routers will give you a destination unreachable if you try to get there. Okay. So that's how you would solve that missing route problem. But we are really interested in what's going on with our VLANs. And so instead of trying to solve the rest of the routing problem with static routing, what we're going to do is OSPF now. And so what I want to do is say, now this is a small topology, so everybody's going to be in area 0. But let's do router OSPF, and we'll pick a process of 1, that's fine. And we're going to say network 192.168.3.0. Remember, we're going to do wildcard mask. Oh, we got a tricky one now. 000 is the easy part, but this is 192. And if we think about wildcard masks as being inverted, we would say 63 and then area 0. And we're going to do the same thing with the 64, because these are the two networks to which router number 3 is connected. Now on router 4, and remember at this point we'll do the simulation for a sec. At this point, router number 3 is looking for an OSPF neighbor. Oh, I forgot to turn off let's do a filter of those. We'll get rid of CDP, DTP, and STP. And there we go. So router 3 is looking for an OSPF neighbor, somebody that they might turn into an adjacency. But currently it's the only one out there. So these are just OSPF hello messages. Go to real time, there we go. All right, let's get router 4 in the game. And we will say, oops, yeah, router OSPF. We still use process 1. Whoops, that's not going to work. OSPF. And we will say, well, we want to do network 3.64 wildcards 63 and area 0. Remember, an important part about OSPF, if these two are on the same network, they better be in the same area. And we're going to do 128 as well. Now in this case, we can see that they've discovered each other. They've said, oh cool, I've got a neighbor out there. This is 125 that it's talking to, and right, remember that this router's IP address is 126. So they've seen each other's hellos, they're going to talk back and forth, and start updating their routing table. Let me see, there was something else I was going to say. Oh yeah, they'll pick their own router IDs, and there's not a whole lot of routers up here, so the designated and backup designated routers really don't make a difference. Let's see if we've learned our OSPF route. Well, there's a directly connected 128 and 64. That's what we would expect for router 4. And there's an OSPF network right there with our OSPF admin distance and metric. Let's see. I mean, right, we're loading on both, so that makes sense. But we should also have the updates here too. And here is an OSPF route that we've inserted. Now it's not an inter-area route because everybody here is in area 0. Well, the hosts have no idea that things changed. So theoretically, we should be able to fire away. We'll have to update the ARP tables because we brought all of the links down. But theoretically, this should work just fine because the routers already know where they're going, and we just have to wait for ARP tables to update. All right, excellent. We'll just make sure that we can get to everybody. And we're ARPing. So what I mean by that, we'll do a simulation here. We'll see if this one hasn't updated yet. We'll go all the way across to 3.1. No, I guess we're ready to go. So what I mean by that is when I say, oh, we're ARPing, for those of you who haven't seen any of the million videos where I've talked about it, everybody's got to ARP first to find, whoever they need to talk to get there. So PC4 here wants to talk to PC6. Well, it checks its host routing table, finds out it needs to talk to its default gateway. So it needs to ARP for the default gateway if it hasn't done that already. Router 3 says, oh, I know how to get to the 128 network. It's via my neighbor here. Let me ARP for my neighbor so I can send that neighbor Ethernet frames. And then we got more ARPing going on over here. So that's what I mean. And so that always delays the first couple of pings if we haven't updated our tables. Now, the reason that we started doing this set of videos is because a couple of questions came in on the tie between networks and VLANs and then eventually OSPF. And over here on topology 1, we saw that, well, I set up a simple routed topology, one router, two networks. But what we decided to do is create a couple of VLANs on our switch here because good engineering practice says you want to segregate the traffic of networks. So we did that. And then we built a static routing topology with 3 switches in the middle. And that was horribly wasteful, so I just collapsed it all into one, created the VLANs. The routers have no idea that VLANs are there. The hosts have no idea that VLANs are there. But what we do is we just set up the VLANs so that, again, we're separating traffic, but also we don't have as many devices, right? So not as much power, not as much heating generated in the closet, and it's less expensive. We don't have to buy as many devices. And then lastly, we took those exact same VLANs, we removed the static routes, right? These routers here have the static routes on them. We use the same IP addresses, except we turned on OSPF instead of static routes. So again, in this case, we're talking about subnets. So every VLAN has nodes connected to it, and everybody in that VLAN has to be part of the same subnet. In other words, the same address space. So 3 chunks of address space, 3 subnets, 3 VLANs. Now the area is completely independent, right? That's an OSPF thing, and you decide what networks are part of the area. The key is the networks themselves have to be in a particular VLAN. And that's really how you think about this. So whenever you create a VLAN, everybody that's in that VLAN has to share the same address space. And it's the same whether or not you're talking about classful networks or subnets. It doesn't matter. The only difference between those two is one chunk of address space is smaller than the other. If we were supernetting, we'd be creating larger address spaces, and those would be in the same VLAN too. So if somebody's on your network or somebody's in your subnetwork, then they better be in the same VLAN you are. And that'll about do it. Well, thanks for watching. Thanks for listening. I hope this helps clear up your routing and VLAN and OSPF concerns. I enjoyed having a little coffee with you, and I'll see you next time. Oh, and, you know, whatever topology you decide to build, may those packets always reach their destination.